Are you guys able to see my screen?
Yes, sir.
Okay. Okay, 1 second. 1 second, 1 second. Give me 2 minutes. Okay, let's get started. 1 second. Okay. Are you guys able to see my screen? Hello.
Yep.
Yeah,
Okay.
yes, Sharat.
Okay, perfect. So today, as we discussed during our last class, we will be starting with Docker containers, and we'll continue with Docker for a couple of more days because that's a pretty big topic. Mm, Before I continue, let me ask this question: did anybody from the class investigate the very last thing that we discussed during our last class? Anybody?
Yes, but not like I didn't get any perfect answer, I would say.
I see.
I
Uh,
looked at it.
Yeah,
A lot of ICMP and like freehand. I mean, are you talking about the freehand way shake, the TCP/IP? That's what you're trying to mean there, or ICMP packet?
Not ICMP or TCP/IP. Let me tell you this. Okay, 1 second. Now.
Uh, I,
Yeah.
I see that it works with the ARP, right? So address resolution protocol. Is that how it is?
Uh,
So it's going to look for the MAC address and then only it's going to transfer the data. So I was only looking for the internal connection. I didn't get enough information on how it connects through the internet with router. So yeah.
okay. So actually, what happens is, uh, in real world, every communication. So let me take this. So let's say I am willing to. There is a command called traceroute, right? Traceroute does what? Traceroute identifies the path between the source and the destination. How it works, it's a different story altogether. I will try to explain it during some other class. Uh, again, these are not things that we are. I'm including in this in the curriculum. These are not part of the curriculum, but still, this will actually trigger some interest in your mind to learn further. Okay. So when I do traceroute to google.com, what's happening is, uh, I mean, this tool somehow, I mean, how that does, I'll explain you some other class. So it shows me what the path my packet is traveling or taking to reach google.com. So there are a lot of networking devices or computers or switches or even Linux machines that are coming between me and my destination, which is google.com. So you can see there are at least 15 servers that are coming in between, 15 machines or 15 networking devices that are coming between me and google.com, and finally it reaches google.com. So how it reaches there, so anything, okay, IP addresses are for actually for us human beings. I mean, of course, for computers also uses IP address, but actual communication does not happen between IP addresses. The actual communication always happens between something called as MAC addresses. Anybody knows what is MAC address is?
Yes, so that's which is hard coded to the NIC cards, right? Yeah.
Exactly. So when you say hardcore to the NIC card, that argument is not fully correct in today's scenario. Just why I'm saying this, imagine a virtual machine. Virtualization is in the picture. I mean, in almost everywhere in the industry these days, right? So, I mean, every NIC card that you're seeing in the current scenario is not a physical NIC card. There is a series allocated to virtual NIC cards as well, which means they are not physical. I mean, they are randomly generated unique MAC addresses, only applicable for virtualized machines. Okay. So, but being said that, whatever you told is correct. That is something which manufacturer, what is it, imprints on the hardware NIC card that you purchase while you ordering the server. So, if you fire up if config command in Linux, you can see the hardware address. So, this is the hardware address of this particular server's NIC card, the exit interface or the incoming interface through which all the network communication is happening on this particular server. So this is the hardware address. Now, every damn computer, your iPhone and your Wi-Fi router, two iPhones together or two laptops together, any networking device, two networking devices communicate with each other using this address. But actually, the destination should always be this address. So let's say, for example, what is happening in this case when I am willing to reach google.com. Okay, so what is the IP address of google.com? This guy right here is the IP address of google.com. 173.194 is the IP address of google.com. So what will happen? My Linux students might remember there is a command that we learned called route. You guys remember this command?
Yeah.
Okay.
Yeah.
So as soon as my computer finds out the IP address of google.com, oh, it is 173.194. Am I part of that network? No, I am not part of that network. I am part of 10.12.4.0 network. So, however, in the routing table, it is written that 0.0.0 should go to gateway. Now, the question is, I should, yesterday, the question I asked was, if the gateway is 10.12.4.1, and the destination, the real destination that you want to reach is Google, that is, so let me write it down so that you guys understand this very clearly. My real destination is google.com, which is this IP address, and gateway, and what gateway is 10.12.4.1. Okay, this one. So if I want to reach google.com, my first packet should first reach gateway server. How will that happen? Simply because if you cannot, in the IP packet, there should be some source IP address, some destination IP address. If the source is my computer's IP address, this IP address, and the destination is Google, then how on earth will that reach gateway server? And if the destination is gateway server, how will gateway know that your packet is destined for google.com? So you can only have one destination address. So either you have to specify google.com, and if you are going to specify google.com, how will that reach gateway? And if you are going to specify gateway's IP address, how will you specify google.com? This is the problem. So what happens is, as I earlier mentioned, every communication between this guy and this guy, between the eighth computer and the ninth computer, before reaching Google, every communication down the line between all these computers are happening using what address? MAC address. uh, IP address is actually being used, but it is sitting inside, or I must say there is a word called encapsulated. So IP addresses, source IP address and destination IP address, and all those details are sitting packed together inside a packet, and that packet is sitting inside something called as frame. So frame, a networking frame, there is a term called networking frame. So frame only deals with source MAC address and destination MAC address. That's it. So in this particular case, what happens is IP address will be like this. Source address will be source IP address will be what? Will be my this guy. Okay. Destination IP address will be what? Destination IP address will be google.com, and there should be what? I told every communication happens between MAC address. Source MAC address is my computer's MAC address, which is this, and I'm going to paste it, and destination MAC address. Here is the trick. In real world, what should happen? Destination MAC address should be the MAC address of google.com, correct? Everybody agrees with me, right guys? Destination MAC address should be the MAC address of google.com. However, this does not happen this way. What will happen is the destination MAC address will be the MAC address of the gateway server. Got it? Destination MAC address will be the MAC address of the gateway server. So gateway server's MAC address. Okay, this is the destination MAC address. Now what will happen when this frame is created and this frame is sent to the networking cable and it reaches the switch or your Wi-Fi router or anywhere, this guy will find out where is this MAC address located. Actually, it does not happen like that. There is a protocol called ARP. So what is ARP? ARP stands for Address Resolution Protocol. Address Resolution Protocol. So what does this do? So here, what did I say? Destination MAC address is the gateway server's MAC address. So my next job is to find out what is gateway server's MAC address. So how will I find out? I'll have to send a broadcast request. Have you ever heard of something called as a broadcast? Hello.
Yes.
Okay.
Yes.
So there is a MAC address that looks like this. This is a broadcast MAC address. So whenever somebody sends a message to this destination address, what will happen? Every computer in the network will get that message. Okay? Every computer will get that message. The question will be something like this. My IP address is this, my MAC address is this, and destination IP address is broadcast and destination MAC address is broadcast. So what will happen? The router will send that message to everybody saying who has the IP address, of this gateway server. And everybody, although every computer in the network will get that message, but everybody will drop it because of course only one computer will have this IP address. And of course others will drop it, and this gateway server will reply saying, okay, my IP address is this and my MAC address is this. Hence, as we know the IP address, we can send a broadcast request to the broadcast MAC address, which will in turn send that request to all computers connected to that network, and gateway server will be the only one replying because gateway server will only recognize its own IP address. Everybody else will not recognize it, hence they will drop that request. Everybody understood?
Sure.
Yeah. So if you see here, one second. You see this? ARP-A. What it is showing? 10.12.4.1. 10.12.4.1. What is the MAC address? 0A:F8. You see that? Hello. So this is the MAC address of this is the MAC address of the gateway server. So my computer knows the gateway server's MAC address. Hence, for all packets that is going outside of my computer, my destination MAC address will always be the MAC address of the gateway server. Hence, as soon as gateway receives this packet, gateway will open this and find out, oh, the destination is Google's IP address, which I don't, which I myself, my IP is not this IP. That is, this is something else. So what I will do, I will forward the packet. So again, what gateway server will do? Gateway server will again modify these two sections and make the source MAC address as its own and the destination MAC address as its own gateway. Gateway server will have another gateway of its own, right? Gateway server will of course have another gateway of its own. You guys agree?
Yep.
So it will modify the source MAC address and make it the gateway server's MAC, and the destination will be the next computer or the next networking device or the next gateway server's MAC address, because all these people are interconnected with each other. This guy will be knowing the MAC address of this guy. This guy will be knowing the MAC address of this guy. This guy will be knowing the MAC address of this guy. And finally, the second last computer that you're seeing over here, ideally second last is this. I'm purposely taking 14th. I'll tell you another reason for why 15th is star star. Okay, let's consider second last computer just before google.com. So this computer will know the MAC address of this IP address. So there will be, see that our protocol does what? Our protocol does the translation between IP address and MAC address. So this guy sitting here, second last computer, will know the MAC address of this IP address. So hence, only this guy is finally able to take us to google.com's IP address. Everybody in the class understood, right, guys? Hello? Hello?
Okay, sure.
Yes. Yes.
Oh,
Sure.
yeah.
So this is something that we configure. Actually, this MAC address resolution, that something happens when we configure it for the gateway, right, for a Linux server. So it's going to request for the MAC address of that gateway server, and it's going to store it, right? Or is it going to do when we send a packet?
It does not happen every time. So what happens is there is a timeout interval. Okay, so it is quite possible that somebody tomorrow goes ahead and deletes this gateway server or installs a new server. IP address will remain the same, but the machine will get changed. If the machine is changed or something like that happens, a new hardware comes into picture, but the IP address remains the same. In that case as well, the MAC address will get changed, right? So for those situations, operating systems implement ARP protocol with a timeout interval. So there will be a default timeout interval called maybe 4 hours. In Windows operating system it is 4 hours, even in Linux it is 4 hours. So after 4 hours, these guys will flush this value and again send a broadcast request. Again send a broadcast to this to grab the latest updates. Why every time before you send the packet it does not happen? Simply because it will add a lot more overhead and reduce the performance. So it is not feasible for ARP protocol to have the resolution done every time you want to communicate with anybody else in the world. However, that only happens once in a while. As soon as the timer expires, again the resolution happens, and then that value will be in the cache till the timer expires. Got it?
Okay, yes. So whenever a packet goes out of this server, so it's gonna be attached with the MAC address of the gateway by default, and that's gonna go to that router. That's how it happens, right?
Correct. And one more thing, guys. Let me grab one of my articles so that you guys will understand one more thing. So you might have heard of different terms that people say. Everybody is interested in in this type of conversation, right, guys? I mean, see, sometimes, I mean, this.
Yes.
Okay.
Yes, Sharat.
One second. Let me search for. I forgot TCP three-way handshake. Understanding 3P. Okay. I just wanted a network diagram. So I'm sure that you must have heard of different terms like this, and people usually get confused because even books are not paying correct attention to or books are playing a major role in confusing people with these different terms. You might have heard of these things, right? Packets. Then you might have heard of a term called segments. Segments. Then you might have heard of a term called frames. Have you ever heard of these things? I mean, nobody knows which one is correct and
Yes, Sharath.
what is the accurate term to use and where to use, right? So what happens is, see this. If I do an if config command, there is a parameter. Once again, let me see. Okay, you see here mtu number. You see this mtu 9001. Go home and execute if config command in your laptop or in your machine or wherever it is. Okay, let me show in any other server. This should not be many servers won't. One second.
9,000 jumbo frame enable, right?
Exactly. One second. So what is that? So MTU stands for maximum transmission unit. Maximum transmission unit. So what is that? So I mention few minutes back while we were discussing about communication that's happening in the internet or between multiple computers, I already mentioned, keep my word for it, okay? I already mentioned the communication happens between only using MAC addresses and they are called frames. So anything that is traveling over the wire is called frame. Now, one second, let me see if here is also, here also it is enabled. Okay, by default, the servers that I'm logging into, right? So these servers have very high maximum transmission unit size, which is 9 kb. So 909001 means they're talking about bytes. Okay, so this is bytes. So it's 9 kb, close to 9 kb. However, ideally it should have something like this. I must say most of the computers, even your home computer or whatever machines that you use as server, will by default have 1500 bytes. So majority of the communication that is happening in the internet will have a frame size of 1500 bytes. 1500 is the maximum. Why? Because 9000 is something that latest routers and switches only will support. Being said that, see that when I want to reach google.com, there are a lot of computers that are coming in between. This server, this machine can be a machine from AT&T. This server can be a machine from another Verizon. Let's say this can be somebody from level 3 network. So there can be different multiple ISPs coming between my source and my destination, and I do not know who supports 9001 bytes and who supports 1500 bytes. So a good bet is to utilize 1500 bytes. Okay, coming back to the discussion. So what is MTU? So I was talking about what you might have got confused by the terms packets, segments, and frames. So actually, what happens? So my application, the application can be a web browser, a web server, anything. Okay, it can be an FTP client. If it can be WinSCP client, it can be anything. Um, let's consider a web browser. So as soon as web browser sends a request to /root.in, an article page, the request, the whole get request with HTTP protocol is constructed over here. Who constructs it? The Chrome browser constructs it. And it is then given to transport layer. So as soon as the thing reaches transport layer, the content that transport layer adds on top of it. So transport layer does what function? It does the job of connection. I must say this is the section where TCP and UDP comes into picture. This is the section where port numbers come into picture. Now leave that aside for a moment. So let me say this. This is the section where connection is properly established, or I must say, this is the section which remembers what happened till now in a particular connection. Or if you are downloading something, this is the section which is actually making internet a connection oriented stuff. This is the reason why web servers knows what happened till now, or client knows, am I connected, am I downloading this, I have downloaded how much percentage of what. These kind of things are actually happening simply because of transport layer. Due to a lot of other details or lot of other options configured inside transport layer, leave that aside for a moment. So things that is created by application layer and sent to transport layer, this guy, when the data sitting over here, is called as a segment. It is called as what? A segment. And did I mention MTU size? So MTU is a property of what? NIC card. MTU is a property of NIC card. Now, the segment size has to match the MTU size. Now, you understood what I'm saying? The segment size has to match the MTU size. Everybody following what I'm saying?
Yes, sir.
Because at the end of the day, whatever is traveling over the wire is frames, and the frames cannot exceed 9001 bytes in this particular example. So the operating system should intelligently select the segment size that matches the MTU size. Otherwise, what will happen? Otherwise, you will end up dissecting that, or you will end up fragmenting it to fit the MTU size. You get what I'm saying, guys? And fragmentation, which means dissecting one larger, what is it called, segment to multiple smaller units, is again time consuming, and it will, introduce a lot of performance lag in the communication between the server and the client. Hence, bottom line is what? Segments, when data is at transport layer, it is called a segment. So after that data reach, after a lot more parameters like port number, destination port number, and other headers, or let's say acknowledgement number. These are very interesting topics. Okay, what is acknowledgement number? What is sequence number? Lot many important topics are there. I will keep that for some other day. But for today, consider this: transport layer adds lot more information on top of the data given by application layer. Informations like what? Did the server acknowledge which packet? Did my next packet is which numbered packet? The destination should understand, right? This one packet, if one segment already got arrived, the next segment is part of which segment, or is it an individual message, or is it part of some other pending message? So it will have all that details added on top of it, and that segment is constructed. The segment is then sent to the network layer. Network layer has a lot more other headers and other values, and it will add source address, destination IP address, then it will add window size, TTL, lot more other values. Will again, as I told, these are all interesting. I will walk you guys through each and every headers of each and every layer, so don't worry about it. So once then, as soon as the segment reaches this third section, it is then called as a packet. This is where packet comes into picture. And as soon as packet reaches data link layer, it is called a frame. So when the data is in transport layer, it is called segment. When the data is in the network layer, it is called packet. When the data is in the data link layer, it is called a frame. Everybody understood, guys? Hello? Hello, guys, are you there? Hello? Everybody hearing me? Hello? Are you guys there?
We lost you on.
Lost.
Chad, we lost you.
For how many seconds? Few seconds, right?
No, network layer or packet.
Packets.
We lost you.
Okay, so data sitting in transport layer is called segment. When it is passed down to network layer, it is called packets. And then the final data that reaches data link layer, it is called frames. Okay, segments, packets, and frames. Okay, so did I say segment selection? Size of the segment is intelligently decided depending upon the MTU size. What happens if by due to some mistake or due to some other different calculation, you have a segment size that is much more bigger than the MTU size? Then what will happen? When the packet arrives, when the segment reaches the network layer will do what? IP fragmentation, packet fragmentation. This guy will sit and dissect that packet, and then so one segment can be formed by multiple packets simply because the segment size is wrong. Segment size might be, let's say, 15 KB, and your maximum transmission unit size is 9,000 KB, 9,000 bytes, which means what? You cannot fit one segment in one single packet simply because this layer won't accept it. So you'll have to do that in two packets. So one segment can be equal to multiple packets. That depends upon how segment size was chosen here in this section. Everybody following what I'm saying here? Hello?
Yes.
Yes, sure.
So segment size selection, I mean, matters a lot when it comes to performance of a network communication. So if you choose the wrong segment size, then one segment can end up being equal to multiple network packets. And just imagine, so this one segment has received and arrived and processed perfectly. You are waiting for that confirmation. So you are indeed, I must say, you are waiting for multiple IP packets to be delivered, and that multiple IP packets at the destination will get accumulated, and then they will recreate the segment, and that segment will reach their destination's transport layer, and then only you will send the next segment, which means this will introduce a lot of performance issues. So let me put it this way: from the source and the destination, the lowest MTU size that the internet accepts, that is minimum MTU size, I must say, must be 1500, in the range of 1500. You know why? Simply because all switches and networks sitting in between will accept that much value. Imagine a situation that you are creating a 9,000 bytes MTU and you're sending it over the wire. Suddenly, when it reaches the fifth hop, this machine will say, "Oh, I do not accept 9,000." So, what you will have to do? There are two things. This guy will respond back to me saying, "I do not accept that." So, I will have to again keep on fragmenting it and send it in the range of 1500. Again communication, again a certain performance degradation happened for the back and forth communication between this machine and this machine, because this will send a response saying, "I do not support 9,000 bytes of MTU." You get what I'm saying, guys? Hello?
Yes, sir.
Okay, so there are two methods actually. Either this server, so generally people think that this server will sit and do the fragmentation and send it with 1500 bytes. Ideally, that does not happen. This server will actually send a response to this guy saying, "I do not support 9000 bytes." Hence, what will happen? This guy will again construct the packet with 1500 bytes and send it so that this guy will accept and forward it. So again, fragmentation needs to happen in this case as well. So this is how, and just imagine, a lot of overhead is happening under the hood while communication is happening over the network. Hence that is the reason sometimes for while communicating with some servers, you have a bad experience. However, sometimes while communicating with some of the machines, you have a super cool experience. A lot more things are into the picture. That's the reason. And in fact, apart from this, error controlling mechanism, how to identify if error happened or not in the communication. Let's say one segment got dropped, one segment was not even reached the destination. How will the source come to know that one segment did not reach the destination. So I'll take that part some other day. So everybody is perfectly clear till here, whatever we learned in today's class, right? Hello.
Sure.
Yeah.
So, where do we specify the segment size actually?
Segment size is also another setting. So it is called MSS value, maximum segment size. Again, this is something sitting inside proc, uh, configured by operating system configuration. MSS value, just Google out for modifying MSS value in Linux operating system. For sure, it is inside proc. I don't remember the file name, but yeah, it is inside proc. Okay.
Okay. So, and that MTU size, is that the size of one data packet that is sent by the application layer to the
Every
transport layer?
not packet. Segment size means the segment that you are actually going to send down the layers from transport layer. In fact, you should not modify that and make it 9,000. That will substantially introduce lag. It must be decided, and I must say the operating system itself does a pretty good job of identifying a default MSS value, simply because operating system has this property of going and finding out what is the MTU size of the NIC card, and then accordingly I will set my MSS value. Because if you are not taking care of the MTU size, then how will you set the MSS value? However, for performance reasons, people do modify MSS value and even MTU size values as well to support or to improve network speed.
Okay. Sure. So then what is that MTU then? Is that the size of the data received from the application layer or
No.
or is
Data, maximum amount of data that can be sent over the wire at one point, at one time. Maximum amount
okay.
of data that can be sent over the wire at one time. Okay.
Got it. So in that case, let's say we have an MTU of 9,000 and segment of 1,500, then it's going to divide that, what do you say? Whatever the packet that we receive, it's going to divide it into like 6 halves, right? Is that how it is?
No. If you have a segment of, let's say, segment will not go that much, but let me tell. Let's imagine a situation. Your MTU size is 9,000. So,
Okay.
and your segment size is of 1,000. Of course, then why do you need fragmentation? You can easily send it right in one single MTU itself. In fact, you have a lot more space left with you.
Okay, makes sense.
However, if you have a segment size of 1,500, you cannot fit it into one MTU, right? Then you will have to make that into two different MTUs. And then, so IP, when it reaches the packet section, that is this area, this guy intelligently will take a decision saying, oh, this cannot be sent in one single frame. So I will dissect it and fragment it and make it two, and then one will be around whatever fits inside that 9,000, and the next fragment of the packet will be the leftover size. You get what I'm saying?
Okay, sure. Okay.
Okay. So let's continue. Okay. So today's topic, or as I mentioned earlier, so we are going to start with something called as Docker. So what is Docker? How it came into picture? That is what we are going to learn today, or what makes Docker so much interesting. In fact, I would say in the coming couple of years, Docker will become the de facto standard. It has already has become, and there are also discussions about in the industry where people have uh, even went ahead and said that Puppet or Chef or other automation utilities will be in danger if Docker is being adopted in such a large scale. So, what is Docker? I'll give you a slight introduction so that you will have a glimpse of it. Uh, let's imagine I want to run an application. So when I say I want to run an application, that can be what? An example can be, we in our Linux class learned about, let's say, MySQL database, right? We learned about MySQL database in our Linux class. What we did, we installed a package. So we need what? We need a package. Second, we need what? We need a service called MySQL running. We need some storage space, and we need a database created inside. So this makes our MySQL application configured perfectly. Uh, every time I want to configure MySQL on a machine, so let's say, for example, Mike from the class knows how to configure, install, and perfectly make MySQL's latest version. Let's say a latest version called 6. 6 version does not exist. Let's say, for example, he knows how to perfectly configure 6. And he is willing to share his methodology, or the way that he found by a lot of research on how to install MySQL's latest version on Ubuntu with everybody else in the class. So how will he do that? He has two methods with him. One is, he can either send a document of his writing to others, everybody in the class. This is one method, of course. But there is a problem. So this is computing, and this is all technical issues. So what happens? It is perfectly possible that one student from my class tries on Ubuntu 14.xyz version, other student tries on top of Ubuntu 15.xyz version. It is perfectly possible that one of the students' machines misses one of the library which MySQL required, and he started facing problems which Mike never faced while he was trying to do that installation. And everything worked perfectly for Mike, but something is not perfectly working for Sharath. Something is not perfectly working for maybe Abhishek. But the error that Sharath is getting is different. The error that Abhishek is getting different. Error that Bala is getting different. So everybody is facing different problems. But Mike was able to run MySQL 6 properly on his machine. So what I'm trying to say here is, agree to the fact that your capability to troubleshoot things will, of course, improve the more you troubleshoot. But sometimes in the industries, wasting time troubleshooting is actually not right. Let me give you an example. I'm actually talking about a problem which IT industry was not able to solve for the last, or I must say, couple of decades. Let me put it this way. Something was working perfectly in development environment, and that same damn thing is not working in QA environment, or it is not working. It was working perfectly fine in every environment, but it is now not working in production environment. Can you imagine the embarrassment? Things were working smooth in all environment, but it is not working in production environment. After hours of troubleshooting, somebody will figure out, oh, the system administrator missed to install one of the dependency package, or the system administrator missed to add a user, or to do something. Whatever that can be. Our top our concentration should not be on the reason of why it failed, but our target should be, the end result should be, things should work in everybody's computer exactly as it did in Mike's computer. So I should not go ahead and face the same trouble that Mike might have went through while he was trying to figure out how to get something configured initially. You get what I'm saying, guys? Hello?
Yes, sir.
Yeah.
So this is going to bring a lot. I must say, a big revolution in the industry. Don't you guys think? You did something, and you are able to share that thing exactly as it is, as if I'm copying a file from your computer to my computer. So uh, this is where Docker steps in. So Docker is not something new. I mean, it was there. I mean, Docker in itself is new, but the concept and the underlying philosophy that it implements is nothing new. It was in the picture for, I must say, more than 10 years now, but nobody ever leveraged it like the company Docker or Dot Cloud leveraged it. Uh, Before that, nobody was using it, or that was not attractive solution, or I must say that was not implemented correctly to make it attractive. So hence, it was not being adopted by so many people in the industry. So let's go back a little bit and understand again, discuss and understand this. So people term this as container virtualization. Container virtualization. So what is this? In order to understand, let's see a diagram. This is how real virtualization looks like. So real virtualization looks like what? You have a computer with a big hardware. When I say big hardware, I'm just considering the fact that that particular computer is going to have multiple virtual computers sitting and running inside. That's the reason I'm saying that that computer might have a big hardware or substantial enough resources, I must say, to make other computers run. So a computer, let's say with 10 GB of RAM and let's say 10 cores of CPU and an operating system on top of it. The operating system is irrelevant in this case. Operating system can be Mac, it can be Linux, it can be Windows. Now what will happen? There is another guy sitting on top of the operating system. His name is Hypervisor. What it does, it will actually create virtual hardwares on top of the operating system. Virtual hardware saying 2 GB RAM and 2 cores and this much amount of hard disk space, and it will create a virtual hardware, another virtual hardware, another virtual hardware, and another operating system will be installed on top of this virtual hardwares that you can see in the diagram. Uh, and again, applications will be running on top of those operating systems. So these are all called guest operating systems. And see that one operating system here, hypervisor over here, another virtual hardware over here, another operating system over here. There are multiple problems here. There are huge problems, I must say. uh, One main problem, can anybody tell me what is the main problem uh, in this approach? Anybody in the class? Hello, are you guys there?
Yeah, Sharath.
Yes.
What is the
Everyone
biggest?
use the same hardware, right? So
The hardware is same, but what
Is it
is
switching between?
no? So virtualization is not fast. I mean, you are not realizing it simply because we are. We are so adjusted to it, and most of the servers that we use today is actually virtualized machines, and actually it is introducing a lot more performance issues. So I will say how it is introducing performance issues. So I told this is a virtual hardware, which means virtual RAM. So think of it this way: if an application running on top of this guest operating system has to communicate or needs a certain amount of memory, it has to send a request to the operating system, this operating system, the guest operating system. The guest operating system will have to send then a request to the virtual hardware. The virtual hardware will have to send a request to the hypervisor. The hypervisor will again send a request to the operating system, and then the operating system will grab it from the real hardware. Can you imagine the amount of overhead sitting over here? So this guy, so memory controlling mechanism of hypervisor is in the picture, memory controlling mechanism of the guest operating system is in the picture, and memory controlling mechanism of the underlying operating system is also in the picture, which means you have to cross multiple layers to access something real. You understand what I'm saying? Hello?
Yeah.
So you will have to travel through multiple schedulers to reach the actual memory. So that is one of the problems. Second problem is uh, you are not actually solving the problem that we were discussing here. Some might argue with me saying it indeed is solving the problem. I do not totally agree, simply because when you say when you say virtualization will also solve this problem, I mean, of course, Mike can do installation of MySQL and whatever he did in his computer, he can do that on top of a virtual machine, and then take an image of that virtual machine, and the image can then be shared. Although that is correct, but it is an idiotic way of doing it, simply because virtual machine images are huge, right? How will you share it? Very huge. They are really very huge. How will you share that? I mean, sharing is not simple. That is one of the case. Second problem is, you are not sharing MySQL version 6. You are sharing Ubuntu 14.4, and MySQL will be part of that Ubuntu. That is what happens when you are sharing a virtual machine image, right? You are sharing an operating system, an application might be part of that operating system while you are sharing it. So you are actually sharing things that does not need to be shared. Why do you want to share Ubuntu? Why do you want to share other things that you have installed on that same machine? So you are ending up sharing a lot more things that you do not even need to. So there exists need for us to find out another method. That is where Docker steps in. That is also the same scenario where Docker steps in. Now, we understood this is the first type of virtualization, hypervisor based virtualization. We'll come back to this a while later. Now, now let me put it this way. Have you, if you have, I mean, my Linux students might know, and everybody else in the class, I must say, might know, what is this number? What is this number, guys? This left-hand side number. What is this left-hand side number? This second column?
The process ID.
Exactly.
Process ID.
So this is the process ID. So I have a process named, let's say, 7. Okay. I just randomly selected one. Or let's take it 10. I have a process number named 10 running on my system. What do you think? Can another process run on the same system with the PID number of 10? What do you guys think?
No.
Okay. So that is simply because this is unique identification number, right? Only one guy can have the same process ID number, right, guys? So
Yes.
what if there is a way where we can have the same PID number running? So when I say this, my end goal is not to have two processes sharing the same PID. My end goal is to have a segregated space for me to run processes without impacting whatever is currently running in the server. So imagine I can have a segregated location inside this Linux operating system. So at the end of the day, what are PID numbers? There might be some entry, process table entry in the operating system, which might be stored inside proc. So proc, from the proc itself, it is pulling down all the directories created in there. What if we have a segregated section where we can construct our own proc directory? What do you think? It will work, right? Hello.
Yeah.
So that segregated section, in fact, no, Docker has never thought about this solution. In fact, Docker is leveraging this solution. There is something called as namespaces. So what is namespaces? So this is a term that is used in most of the times in Linux industry as well as in many operating systems. So what is namespace? Namespace is nothing but a segregated section. So you cannot have two PID numbers with the same number 10 in one namespace. Now you understand what a namespace is, right? Namespace is what? Namespace for PID numbers, namespace for networking. So you cannot have same ETH0 on the same computer, right? So let's say if config. So you have two NIC cards. So two NIC cards name should be different, right? You cannot have two ETH0 on the same computer. Do you guys agree with me?
Yes.
Yes.
And you cannot also have /etc two times, right? One only, you can only have one /etc. So what I'm trying to say here is file system hierarchy can also be unique. So we needed a method where we can create uh, what is it called, segregated sections for different things. When I say different things, I need a namespace for PID numbers, which means I can have my own process IDs. You won't believe, guys, PID number one, I can have the same PID number one running in here, and in also the same PID number one running in my segregated section, in my segregated namespace. So different namespace. So I can have my process with the same PID number. I don't care. So I can have that. I can have ETH0 as well. Again, ETH0 in my own segregated space. I can have same /etc in my own segregated space. So this is what namespace is all about. So whatever I explained is in layman terms. I would not recommend to you guys and go ahead and learn namespace in detail, because so many experienced even programmers do not know what namespace is. So this is all about kernel programming. How Linux achieves it is out of the scope of this class itself. Okay, so namespaces. Now, apart from namespace, uh, uh, think of it this way. Okay. So we have, I must say, we have everything that we need to construct something that we were discussing earlier. So Mike knows the solution. Mike knows the method to install MySQL version 6 on Ubuntu 14.4, and is willing to share it with everybody. So we have ruled out the method of virtualization. We are going to the track of containers. So what if we have a method where we can create a small segregated file system hierarchy structure? When I say file system hierarchy structure, a segregated /etc, a segregated /bin, segregated /blah blah, everything, and a segregated namespace for PID numbers, and a segregated namespace for network interface cards. Now, what he will do, he will go ahead and fire a command in his computer saying create a segregated namespace for PID, for network, for file system hierarchy for me. Then what will happen? He will then ask the computer to take him inside that segregated space. He will go inside that segregated space and fire all the commands that he needs to in order to set up MySQL package installation. He will install it, and then he will come out, and then he will tell the computer to take the snapshot of that segregated space. Snapshot of that segregated space with all the PIDs, all the file system hierarchy, and all the network interface. Then that snapshot can then be shared with everybody else. Or I must say, Mike can in fact share. So let's imagine this. So if you remember, I told if I am going to try and execute all the things that Mike did myself by my bare hands, it is quite possible that a mistake can arise. I mean, I might miss one of the methods. My system might not have one of the libraries. That is the problem. That is the main problem that we were discussing earlier. Now, what if Mike again has a feature where he can share a source code of whatever he did? When I say a source code, what what if he has a method where he can actually series wise, okay, he can say this step 1, okay, let's say install MySQL, step 2 install XYZ library, step 3 add user, or whatever it is, add user. And there is an external process that will step in and create a segregated space for file systems, for processors, for network. And on top of this, this is the source code given by Mike, and we will tell that inside that segregated space, execute this source code given by Mike. So what will happen in everybody's computer? Whoever is willing to try out the method suggested by Mike, they will first fire up some command, which will end up creating a segregated space, a namespace for everything. And then what will happen? Then you will tell, I have a source code with me, and you go ahead and execute it. That source code, that program will travel through each and every step and execute each and every operation. And then finally, we have whatever Mike had in his own computer. You know why? Because the environment is exactly the same. Environment is exactly the same. Or there is another method. Mike can simply take a snapshot of his segregated space and share it with everybody. That will be around 100 MB or 200 MB. Just imagine. Because the segregated slash etc does not have all the junk that a regular Linux etc has. It will only have slash etc MySQL. You get what I'm saying? It will not have any other junk that a regular slash in Linux slash etc in Linux has. It will only have MySQL specific component. Rest everything will be blank. So if Mike is willing to take a snapshot of his segregated namespace for file system, for process ID, for network, he can then share that with anybody in the world and give you the guarantee as well that this will work in anywhere in the world. That is going to work in Mac, that is going to work in Ubuntu, that is going to work in even Windows. Do you guys agree with me? Hello.
Yes, sir.
So that will be why it will work, simply because it is similar to sharing the virtual machine image, but this is lightweight because you are not sharing the entire operating system. Let me reiterate that statement. You are not sharing the operating system. You are only sharing the segregated namespaces that you created along with only the contents that you had in that image. Contents might be the whole MySQL might not be about 80 MB or 100 MB. So that file, I mean, MySQL library files and MySQL itself installed inside that file system segregated space, that can be created as a snapshot, and then that can be later on shared. So this is where Docker steps in. All of this is achieved with smooth series of commands and methods is what made Docker so popular and people started adopting it. So we have solved industries one of the most discussed about problems that nobody was able to solve till now. So imagine this. I have a perfectly available source code with me, which will take care of installing MySQL version 6. And that is going to work in every laptop, every server, everywhere. In whichever machine Docker is supported, it will run for sure. So that is the guarantee that you have. So slowly, by getting adjusted to this technology, you will understand the strength of it. Although there are problems in it as well. I mean, simply because people have started adopting it and making it fit in everywhere, that I do not actually subscribe to that argument of Docker is going to solve every problem. No, it's not like that. I mean, Docker will actually solve a lot of problems, but not everything in the IT industry. At least I believe you guys got an idea of what Docker is, right, guys?
Yes, sir.
Another important thing, when Mike is creating his segregated space for MySQL, uh, he is only creating what? Directory structure slash etc slash proc slash opt slash blah blah, whatever it is in the file system hierarchy. He is not including the Linux kernel. Can you imagine that? His snapshot with his segregated space where he installed MySQL can be shared with anybody in the world. And it does not matter if I'm running CentOS, if you are running Red Hat, if I'm running Ubuntu. We can all download Mike's snapshot and we can run it anywhere. only requirement is Linux kernel. It should be Linux kernel, or Linux compatible kernel. Now what will happen? Linux kernel will, so when I say an operating system means what? The kernel itself, right? So you are not sharing the operating system here. It, unlike virtual machine images, virtual machine means what? You are sharing the entire operating system along with the kernel. Here the kernel will be the same kernel of your computer. You are only using the segregated namespaces, segregated section for that application to function smoothly. You're not using anything else at all. Which means what? In this particular case, all these virtual machines are having their own individual kernels, right? See, this guy will have this operating system kernel, this guy will have this operating system kernel, and this as well will have its own operating system kernel. In this case, this is how containers look like. This is the hardware, of course. This is our kernel, that is our operating system, main operating system where we are sitting right here, and then it will have multiple containers. Consider this as something shared by Mike, this as something shared by any other, this as something shared by any others. So basically, these are all different snapshots shared by different people, and it also has applications. It might be MySQL over here, it might be Nginx over here, it might be something else over here. And this is only what? A segregated space for file systems, segregated space for PID numbers, segregated space for uh, network interface, and everything is being administered by the main kernel of the underlying operating systems. However, we are simply naming this collectivity of segregation as a container, and the kernel will allocate resources to it as the kernel allocates resources to any other application running on the server. Everybody understood the difference? Hello?
Yes.
Okay, the
Yes.
host. So the
Yes,
kernel,
sir.
there is only one kernel, that is the host kernel, and the containers will not have a kernel. This is the primary difference. If anybody asks you in an interview what is the difference between uh, what is a hypervisor based virtualization and container based virtualization, this is the main primary difference between those two things. Okay. Uh, One second. Let me see. I have covered this. Sorry. Okay, one second. Okay. So let's go ahead and do what? And install Docker. Let's go ahead and install Docker and then see what goes under the hood, and let's go ahead and see some of the basic commands of Docker. Actually, Docker is actually designed in such a way that it is actually going to take care of only one process. I mean, I am not trying to say that you cannot do multiple process, but it is a good idea, or I must say the recommended method, to only keep running one single component at a time inside the container. What does that mean? That means I told Mike is going to do what? He is going to share MySQL and the methods to install MySQL or to make it run perfectly. So, to with others. So, if Mike is going to do that, mm, uh, one second. One second. Mike should not include any other things inside that image. So that is the philosophy of Docker. Mike should only keep MySQL and that's it. Apart from MySQL, he should not include any other thing inside his container. When I say that, he should not think of including Nginx. He should not think of including any other stuff like Redis or Memcached or any other thing, or even Apache or anything like that. He should only, so what I'm trying to say here is the philosophy of Docker, the philosophy of containerization is one process, one application equal to one container. So one container, the container or the, I must say, the container will be alive till the application is alive. As soon as the application dies, the container will also be dead. We will, I mean, you might be confused when I said that last statement. Of course, that is quite confusing. You will be able to understand what I'm trying to say while we practice things. So container will be alive till the application is alive. Because why did you create the container? You created the container to run the application. If the application is not running, then you are going back to virtualization, right? Just imagine this. If the application is not running and the container is running, then what are you trying to say? You are trying to say that it is a server. You can log in and fix it. No, it does not work like that. If the application is running, then the container is available. If the application is not running, it is dead, then the container will also be dead. Everybody understood what I said?
Yes, sir.
So containers primary objective is to provide an environment for that particular application to function smoothly. So as soon as the application is gone, that environment is not even required. So basically the container is only living. It's only the goal in life of a container is to make that application function smoothly. As soon as the process is dead, container is gone. I'll show you an example and you will understand it. Slowly we will walk and understand these examples. Let me go ahead and install Docker so that you will understand what I'm talking about. Okay, Docker. Oh, sorry. I have to get install docker.io. Okay, let me install this, and once this is installed, we will then be able to play with Docker containers. Okay, this is installed. So we have currently installed Docker. Installation is again so very simple. So two apt-get commands away simply, and in the case of Red Hat base, it is install Docker. Okay, now let me see. There is a command called docker space ps. So the main command that we will be utilizing while using Docker container technology is Docker. So this is the primary command that we will always be using. Uh, one second. One second now. Okay. So there is a command called docker space ps. What does that do? Actually, let me come back to this command later on. I will not show this command right now. Let me see. Okay. So there are actually multiple things in the picture. Docker, this guy right here, this Docker, this command is what? This command is nothing but, one second. This command is nothing but Docker client. So Docker command in itself, command line in itself is what? Nothing but the Docker client. There is something else called Docker server. Okay, so Docker client command is always communicating with Docker server. So Docker server is the process that is running in the server right now. So if you see ps of grep docker, you can clearly see a Docker process is running. This is the Docker daemon. So this Docker command is actually communicating with this Docker server. So Docker is a client server mechanism. Okay. Now there is another thing. There is another thing called as Docker container, which can be viewed by using Docker PS command. Docker PS will show you what? Docker PS will show you this. How many containers are currently running and what each of those containers are named and their details, which we will see shortly. Okay. Uh, one second. Okay. Let me actually go ahead and run a container so that you will understand how this whole thing is constructed. Okay. Let me do this. Not this. Once again, now let me. Once again, guys.
Correct.
One second, one second. Hold on. Huh?
Yeah.
Yeah. Yeah. Tell me, Bala. What were you telling?
Uh, so this container, it's like a file system of its own, right? So is that what a container is?
Mm, file system is one of the property of its own segregated world when we talk about containers. Apart from file system, yeah, in a way you can say that because at the end of the day, most of the rest of the things is also part of the file system. But apart from that, let me put it this way: you also need a mechanism for the underlying. If it was only file system, how would the source kernel will communicate to that? You get what I'm saying? The source kernel needs to have a method to communicate to that container with the segregated file system as one of the feature. When communication happens, when I say source kernel is able to allocate resource to the container, what does that mean? That means source kernel is still able to communicate via some channel to that container. You agree with me?
Yeah.
So that means it is not only a segregated file system, but it is a segregated space for running processes with a segregated file system. Got it? So kernel knows about everything what a container is. What a container is, it is nothing but a segregated namespace for process and networks, and it is a segregated space where you can have your own slash etc, your own file system hierarchy, simply because you can have your own specific programs inside and take a snapshot and share it with people. So while you are sharing what? You are sharing that file system hierarchy structure that you created, segregated in your computer. While you're sharing, of course, you are absolutely correct. But when the guy with whom you're sharing it will download that file system hierarchy structure, and he will run the container, as soon as running concept steps in, that computer will create what? Again, a segregated namespace for process network, and use that base file system hierarchy which you shared, and then it will kickstart the process. Understood?
Okay, sure. Okay. So, uh, so that container can contain n number of applications, right? So, and it,
It can, but it is not a best practice. So that's what I said. By considering that Mike's example, that Mike is only willing to share MySQL, although he is also willing to share Nginx and other things with others, but still that should be shared via a different image or a different container. So the Docker or container philosophy itself is one container, one process. Simply because you think of the idea. The idea is what? In order to what the main problem that Docker is solving is what? That it was working perfectly in dev environment, it is not working in prod now, or it was working in my computer, it is not working in your computer. So when we say I want to share MySQL, I should not include anything else that might be an hindrance to MySQL, simply because MySQL, the container's primary goal in life should only be to run MySQL properly and kill myself or kill the container itself if the process is dead. So that is the goal in life of a container. Uh, then only it will work, right? Otherwise how will you, I mean, otherwise then again we are back to virtualization. You are what is it, stuffing things up in the same container. You get what I'm saying? So you can create another segregated space for Apache, another segregated space for Nginx. What is the beauty of it? The beauty of it is when Mike wants to share 6.2 MySQL version, I can simply grab that particular version of MySQL from Mike. You get what I'm saying?
Okay, sure. Okay. So, and also you said that particular snapshot can be installed on any different type of operating system, right? So,
Although I made that sweeping statement, I would say Nix family of operating systems. Okay, primarily. I mean, although Docker has officially announced the supporting on Windows, but they have nothing is yet concrete or nobody is using it in production level environment. Uh, Simply because the feature that Docker requires, namespaces and C groups, these are the two kernel features that Docker containers are using. This is supported by Linux itself, Linux kernel. And I must say, any Linux distribution, okay? Any Linux distribution, Docker will work. That is the first point to understand. Second point is it will work on top of Mac as well. So Mac earlier, I mean, natively Mac will currently support Docker simply because Mac is also using the BSD kernel, Darwin kernel, so which is very similar to Nix, and it supports namespace and C group features that Docker is using. So Mac and Nix family of operating systems, but not Windows as such. I mean, although they announced it, nothing is rock solid yet. Yeah,
so one last question.
yeah. Shoot, man, no problem.
Yeah. Okay. So, so let's say we have a container for say Apache. So, Ubuntu has the user and all those details as dub and data, right? So, and when it comes to CentOS, the username and everything, the configuration, it's all HTTPD. Sorry, HTTPD, right? So, so that's something which Docker knows, right? So,
No,
it's
no, no, no.
all
Think of it this way. Think of
or
it this way. Think of it this way. Uh, you remember this command? This will tell what? This will tell our kernel version, right? 3.13 something, right? This is our kernel version. So my primary concern is only my kernel. Have you ever noticed something? That the file system hierarchy structure, at least the file system directory names, at least the hierarchy names are exactly the same in almost all distributions, right? At least these things are same, right? Bin will be there, boot will be there, dev will be there, etc will be there, home will be there. You guys agree with me? Even in Red Hat and even in CentOS and even in Ubuntu, right? But of course,
Yes.
yes.
apt-get will be different. Here, Debian packages will steps in .deb. There it will be RPM. There it might be some other commands. So that means what? When I say command means what? Command means something sitting inside slash bin, right? What is a command? I mean, if I type ls, I have a command called where is and find out where is ls located. So it is something sitting inside bin ls. So which means if I have a segregated location for file system hierarchy, I bloody don't care about this file system hierarchy, right? Irrespective of where it is. So imagine Mike started his Docker container on top of Ubuntu base file system hierarchy. That base file system hierarchy will come over here and sit in a segregated different space, and it will work exactly as it is. And it only needs Linux kernel, which we have. Kernel is the same across all distributions, so it does not matter at all. So imagine we have a small tiny Ubuntu file system hierarchy running on top of an underlying file system hierarchy of CentOS or Red Hat. So again, what makes a distribution different? It is nothing but small programs, small commands might be different, or appearance might be different. So that is what is making a distribution. But if you have Linux kernel and Linux kernel supports the features that Docker containers requires, then you can run anything on top of anything. You get what I'm saying?
Okay, sure. Okay.
You understood, right?
So
Shortly, you will understand more. So think of it this way: Docker people, what they did. I'll one second, no, Docker.io. Oh, not IO, man. I think I fired up the wrong website. Yeah, this is the website. So let me images. Where is Docker Hub? Sorry, I fired up the wrong website. So this is the website, dockerhub.com. Okay. So one second now. Let me log in first. I forgot my. This is the problem. Oh fuck! One second now. Uh huh. Ah, thank God. Okay. Dashboard. One second. I'll tell you what I'm seeing. See, I just searched for what? Ubuntu. So Docker people, what they did, they created a, a, a image or a snapshot of Ubuntu operating system, which means you can pull the segregated file system hierarchy for Ubuntu distribution and base your work on top of it. Let's say Mike is more knowledgeable in terms of Ubuntu rather than CentOS. If Bala is more knowledgeable in CentOS or Red Hat, then he can opt for CentOS file system hierarchy to base his work on top. So irrespective of what underlying main operating system is, Mike or Bala can select their own choices for their segregated file system hierarchy for Docker containers. Simply because it might be very simple to install MySQL 6 on Ubuntu compared to Red Hat. Red Hat might have some more glitches. So it depends upon who is designing the container. They can take that decision and they can actually create a segregated space that matches different distributions. So I am sitting in Ubuntu. Okay, currently I am sitting in Ubuntu. I have the facility with me where I can say, create a segregated space with an image called Ubuntu 14.4. Of course, when I say with an image called Ubuntu 14.4, this is similar to saying, uh, consider this location, hub.docker.com, as a central repository where people have created base file system hierarchy structure for different Linux distributions. So they have created file system base hierarchy structure for Ubuntu 14.4, 15.4, 12.04. They have created for different Linux distributions and they have kept it there for anybody to use. So what we will do, we will go ahead and download that, and that our work will be based on top of it, which means as Mike is setting out to build his image, what he will do? He will say, start with the base container image that is provided by hub.docker.com, and that base image will be Ubuntu 14.04. And on top of that, he will create, he will do his own steps. That might be download something from internet for MySQL, install that, install this, whatever that might be. He will do his operation. And then he creates the final container. So the base file system hierarchy structure is provided and is actually, to be honest, irrelevant as far as Docker is concerned. If your application is working in Red Hat, you can make it run on top of the base Ubuntu. If the application is working in Ubuntu, you can make that container run on top of Red Hat. Hope you guys got an idea. Right, Bala?
Yes.
Everybody got an
Understood.
idea?
So
Yeah. Okay.
So is it not going to cause any overhead? Because right now the kernel has to communicate with the Docker container, right? So
So
that's like an
no, it is
additional
not.
layer, right? So
It is not at all creating overhead. It is similar to saying I am right away running a process. Let's say I am. It is similar to saying service MySQL start, right? Nothing else. It is only consuming maybe 100 or 150 MB of more space in some other location for that segregated store file system hierarchy structure. And on top of that, I have my process running. So the PID numbers are only getting changed. Everything is under the hood handled by the same kernel. Got it? Okay, so let's run our first Docker container, and you will be now things are going to be more clearer. Okay, I'm going to fire up a command called Docker space run. Okay, run hyphen I. Don't worry at all. I will explain what these commands and these parameters means. Hyphen I hyphen T, then I will say Ubuntu, Ubuntu 14.04, and then I will go ahead and say bin bash. What is this? I will explain you. Don't worry about it. I will explain each and every component of it. I am going to press enter. Now you see that something is being downloaded from internet. You see that? There was a line saying pulling from Ubuntu. See that? There is a line that is saying pulling from Ubuntu, and there is something that downloaded an image for Ubuntu 14.4. So what just happened? Do you know what just happened?
it downloaded the Ubuntu 14.2 version. So
Exactly. So not the operating system, the file system hierarchy of 14.4 from hub.docker.com. Okay. What it did, the first step is I specifically told I want Ubuntu 14.04. So it went ahead and downloaded that file system hierarchy structure from hub.docker.com, and then it did what? Then it did what? That is what is interesting. Now, do you see something strange? See the screen and tell me what is strange over here. Something got modified.
Got a new image of Ubuntu.
What?
Got a new image of Ubuntu.
No, that is fine. But see the shell console. Something got modified. See that? See the console. See earlier.
Oh, okay. The host name.
Exactly. So everything got modified, right? See that? I mean, I'm getting the feeling that I'm actually sitting in a different server, right? I'm a different machine. So actually, we are sitting currently inside the container. So we are currently actually sitting inside the container. Now, do you remember I specified a few minutes back that Docker is designed in such a way that it is one process equal to one container. So I needed some dummy process to showcase you the working of Docker container, right? I mean, why would I go ahead and install MySQL if I have bin bash with me? So bash is also one process, right? So similar to MySQL, as far as processes are concerned, whether it is big or small, process is a process. So I told Docker to consider bin bash as a process to run inside the container. So when I say Ubuntu 14.4, keep in mind everybody's effort in the Docker field is to create something extremely lightweight. So when I say I have a base image, this is called a base image. Why it is called a base image? Because my work on top of container will be based out of this image. So my work will be done on top of this image. So what I'm trying to say here is when I say Ubuntu 14.04, what is it is an entire segregated file system hierarchy with necessary things involved. It is not simply a collection of slash bin or slash etc. It is a collection of slash bin ls, slash bin vi, slash whatever is necessary commands. That necessary commands can be anything. I mean, of course, you need to have bash there. Otherwise, what is segregated file system? If you have a segregated file system hierarchy, and if you want to log into that segregated file system hierarchy, you need to have bin bash inside that segregated file system, right? Otherwise, how will you log in? So, see, let's travel over there. Okay. See that bin? If I do an ls inside bin, I have lot of things sitting in here. See, I have bash, I have echo command with me, I have ln command, linking feature, ls login, ls mode, I have grep, more. All these features are at my disposal. That is regular Linux commands. Are you guys following me? Hello?
Yes, sir.
And
Yes.
this was part of, this is all part of this particular image which I pulled. So currently I am sitting in a different container. If I fire up if config command, you can clearly see another IP address, 172.17.0.1. I will come to this networking part later on. That is a different discussion altogether. And you can see different IP address. And for your information, see that the older IP address was this. If you remember the IP command which we fired earlier, you see that this was the IP address of our. This is the IP address of our real server, our virtual machine. But the container is having a different IP address. Do you remember I told a segregated namespace will be created for network as well? See that ETH0, same ETH0, but the IP is different. So how can same ETH0 exist in the same computer? Hence, a different namespace for network as well. Do you guys agree with me?
Yeah.
Okay, so we now have what? A segregated space. Uh, Again, base images are available for us to use from hub.docker.com. They will have all base file system requirement. So if you have basic commands, you have basic what do you say, components like home structure and run directory, temp directory. You have all the basic stuff that you need in a Linux distribution. But you won't believe, guys, it is only 150 megabytes of data. So I strongly believe if you are constructing an application and making it in the range of 150 or 200 MB, that's a great achievement. Simply because you are 200 MB in today's internet is nothing big. You can share your application with anybody. So imagine Ubuntu's container image is 100 MB. Your application, after installing on top of this image, becomes 200 MB. So 200 MB is a viable option for anybody to share applications around the globe. Uh, there is a lot more interesting stuff to unravel this. You might be still confused, or still a lot of questions might be arising in your mind. Don't worry at all about it. So, because as we slowly go further, things will get clear in your mind. Okay, don't worry about it. Okay, then let's stop here today. Let's catch up tomorrow, same time, and continue from this point onwards. Okay.
All right.
Okay.
Thanks, sir.
See you.
Okay, guys. See you guys tomorrow. Okay. Bye bye.
Yeah.
Bye.